Because so much ore is needed to make steel, everything works on a mind-boggling scale. The crude ore is snapped up in buckets big enough to hold a car and dumped into trucks the size of houses.
Going down into the bottom of the pit to load LC ore for the crusher. Should be right around 200 tons, give or take.
Their goal? To transform these rocks that are about 25% iron into a concentrated 62% iron pellet. At that concentration, it can be usefully smelted. But first, you have to get rid of everything else. Step 1 is to crush the chunks of taconite.
You virtually have to beat the iron ore out of the taconite to obtain anything usable.
Operating like a 900 horsepower mortar and pestle, the primary crusher busts boulders at a rate of 3,000 tons an hour. Then 800-pound steel rods pulverize it into the consistency of sand. But why all the pounding? The answer is that it makes it possible to use iron's secret ability to separate it from all the other junk. Magnetism.
Magnetism is actually an element of the electromagnetic force, which is actually quite a bit stronger than gravity. A bar magnet like this one. There are electrons in here, and each electron is itself a little tiny magnet.
You know, if you superimpose a magnetic coil around them, all of a sudden you get one electron spinning, the other one that was going randomly, all of a sudden it's going successfully together.
And that lets giant magnets suck the iron particles away from the waste minerals, because only iron is attracted to the magnetic force.
The nifty thing is when we are going to ores like taconite that is very high silica content, we break up the particles. One way of easily extracting that is actually to use magnetic separators.
Of course, this still isn't pure iron. Most of the other impurities have been crushed and sifted away. But there's still one left: oxygen. And breaking that bond is one of the greatest challenges in modern industry.